everybody. This is a preview or a review of Introduction to Circle vocabulary and terminology. So a couple of things that we need to make sure that we recognize when you have a circle. The center point is usually labeled with a capital letter. So for example, this would be circle A. Or they might say circle A like this. So that's what a circle is, the collection of all points in a plane at a fixed distance. Also in a circle there are several pieces which we should already know. A radius goes from the center of the circle to the outside. A diameter goes from one side to the other through the center. It's a chord. It's a special chord because it goes through a center, and then there's also a chord that does not go through the center of the circle. It's very important that you know the 3 different vocabulary words for that. Pause if you need to get these notes. A reminder that the radius is half the diameter, and a reminder that the diameter is twice the radius, just so that we can remember that. Exercise 1 talks about a specific circle. So it says circles are often denoted by their center. In this case, it's center A. In the following diagram, circle A is shown with points B, C, D marked on the circle. List the segments of the radii. So AD, I'm going to list the center of the circle first. You could certainly go backwards and say DA, but I'm going to list the center of the circle first. AD is a radius, AB is a radius, and AC is a radius. And remember, the line that's above those letters just means it's a segment. Give the segment that represents the diameter. You have to choose the one that goes through the center, the segment that goes through the center, so it's DC. If you want to say DAC, that's perfectly fine. Again, the question says, what is the relationship between the length of the diameter and the length of the radius? 2 times the radius equals the diameter, which I believe you know. Again, this is a review. Or half the diameter equals the radius. List all of the chords that are drawn. In this case, DC is a chord, but it's a special chord because it's a diameter. The other chord that is drawn here is DD. And explain why DAB is here, why that is an isosceles triangle. DA is a radius and AB is a radius. So you would say since DA equals, we'll go with the center first. So AD equals AB, and because they are radii, then the triangle is isosceles. And isosceles, remember, has 2 equal sides. It also has 2 equal base angles. Pause if you need to get all of these notes. Exercise 2, you actually don't have a picture, so we're going to draw a picture. It says in circle M, so circle M means the center of the circle is represented by the letter M. It says A is located on the circle such that AM, which represents a radius, is 2x plus 7. The diameter of M is 74 units. So in other words, if I go across this shape, the diameter equals 74. And the question says, what is the value of x? That means that it takes 2 radii to get to the diameter. You could also write it like this, 2 times the radius equals the diameter. Either way, you get 4x plus 14, oops, that should be a 74, sorry, equals 74. 4x equals 60, and x equals 15. The question is asking for x, so we do not have to go any farther. Pause to get the rest of these notes if you need to. Circles also have arcs in them. An arc is when you have 2 points that are on a circle, and so this would be called arc AD. It says when 2 different points lie on the circle, they divide into 2 distinct portions. There could be several different portions. That's what an arc is. In the diagram of circle O below, A, B, C, and D are on the circle, and BD is a diameter. It says name the minor arcs and major arcs that have A and B as their endpoints. So basically we're focusing on these 2 points. The minor arc is arc AB. The major arc is arc ADCB, or you can name it with 3 letters. You can also name it ADB or ACB. The endpoints have to be the first and last letter that you see. So minor means smaller arc, and major means larger arc, and you have to use those endpoints. So along the same lines, if you have to use endpoints A and C, A is here and C is here. Minor arc will be ADC, that tells you the direction to go in, whereas major arc will be ABC, because that's larger. You have to make sure to go in the correct general direction. I believe the next slide also has this paragraph right here. We're going to talk about central angles. Please remember, we talked about central angles before. Central angles touch the center of the circle. So this angle C is a central angle. Angle C touches the center of the circle, and let's say it's created by arc AB. In this particular case, the measure of the angle C equals the measure of arc that is created, in this case, AB. So if this is 75 degrees, then the arc is 75 degrees. Really important for you to recognize the measures of central angles. Pause if you need to get all these notes. So again, the paragraph is still on here. We kind of drew a picture that goes with this. So central angles touch the center. In this case, it says circle B is shown to have various points within it. Which angle below is a central angle? So if we look at this, DAE does not touch the center. This is actually an inscribed angle, touches the outside of the circle, so that is not the choice. CEB again touches the outside of the circle. This is again inscribed, so therefore it is not the central angle. It doesn't touch the center of the circle. CBA does touch the center of the circle. And ACB, again, is called an inscribed angle because it touches the outside of the circle. And finally, the last question on these notes. Now that we know the central angle is, we can define it. So for example, in the diagram below, here's a central angle because it touches the center of the circle. That means that arc AB is also 112 degrees. Central angles and arcs have the same measure. The arc of A to C to B, there are 360 degrees in a circle. 360 minus the 112, is 248. Make sure that's right here, that I'm adding correctly. 248. So arc ACB is 248 148 degrees. Please make note of this, that's an additional piece of information. When you have a circle and you know the diameter, please remember that the arc from one side of the diameter to the other is 180 degrees. There are 360 degrees in an entire circle, and so therefore each half of that circle, a semicircle, is 180. Make sure you have these notes filled out. Your homework is to do pages 3 and 4. Thanks. Have a great day.